Hi. It's always exciting when Keysight release a brand new oscilloscope because it doesn't happen that often, especially in the lower end market. In fact, the last time it happened was just over 6 years ago, way back when I was working in the garage and I did the review in the garage of the original Keysight 2000X and 3000X oscilloscopes. And they made a huge impression in the market. You could say almost practically game changing with their built-in function gen and their high-speed Megazoom 4 ASIC and everything else. It was absolutely fantastic. But 6 years later, they've released the brand spanking new 1000X series, which uses the exact same Megazoom 4 chip that we saw 6 years ago. So they're still trying to eke out the return on investment on that Megazoom 4 ASIC that they had to design. And, well, no doubt, it probably costs them cheap as chips now. But it's amazing that we can now get that Megazoom 4 ASIC technology in a $450 scope, and that's what this one starts at. This is the top of the line unit, the 1102G with the built-in function gen, and I'll be doing a separate review video on this, so I won't go into it. Anyway, 2 gig samples per second, 100 megahertz, only 2 channels, but it's got the built-in function gen and it's got the demo stuff, same as the 2000 and 3000X series. And for those who do want to see the size difference, it's pretty substantial. And against the industry benchmark in low-end scopes, the Rigol DS1054Z, they're practically identical in size. Now, as far as the look and feel of it goes, it's exactly the same as the 2000 and 3000X series. The knobs are identical, the indents, everything else, the indented feel of them is absolutely identical. And as is common with practically every low-end scope on the market, they emit the automatic x10 probe and the probe power interface. But, you know, you expect that. And it's got quality tilting feet like that with the rubber at the back. It ain't going anywhere. It feels really nice and solid, well built, even kind of like the new sort of styling look on the thing. Anyway, this ain't a review. On the back, you got power, and you've got USB, that's it, no LAN, thank you very much. And yes, it is made in China, not made in Keysight's Malaysian facility, so I'm not sure if it's a Keysight facility in China or whatever, but it is not a rebadged scope. I want to make that clear. It is not a Rigol, it's not anything else, it's 100% designed and manufactured by Keysight. But who actually manufactures the thing on what line? I don't know, but it's somewhere in China. So you know what we say here on the EV blog, don't turn it on, take it apart. And just like other similar scopes, 2 screws here, 2 under there, and this whole panel will lift off, but expect to see a lot of shielding because this thing ain't light. So they promote this and have a slogan, scrap the toys, get a real oscilloscope. So we expect to see real oscilloscope quality in here. Any rust on the chassis? Nope. Now you can't hear it on here, but the fan is kind of annoyingly just on the loud side. Like it's not howling, but it's noticeable in a quiet lab. Yeah, I don't like it. I think it's a bit of a fail. And we've got a real clunking mains power switch, none of this soft power rubbish. And yes, confirmed it does actually draw 0 power. And the folded metalwork looks typical for a scope like this. Yes, we've got our proper RF fingers here, no worries. There physically is nothing on the board down in there for the Ethernet interface, so don't get excited there. And external BNC is just not there, but they put them in the metalwork, so who knows. All right, let's get straight into it. Quite a few screws around the outside here, and let's pop it open. Ta-da! We're in like Flynn. Oh, look at that. 2-board construction. Look at this. I haven't seen this in a Keysight scope before, but we've seen it in other low-cost ones, notably the Instec, I think it was. A separate board for the Megazoom 4 ASIC and the ADC and the main ST ARM processor and another Xilinx FPGA. So all the logic. So this is interesting why they've done this. What is it, for an upgradability thing? I don't think so. But possibly they split it out maybe to 2 design groups perhaps. And then, you know, they thought, oh, we can, you know, tweak the processor and everything later, keep your design decisions further down the development, your final decision on what you're going to include, what you're not going to include further down the process rather than to have to respin the top motherboard. But of course, it's going to cost you more to put it on the separate board like that with the connectors, in theory, anyway. It's going to cost you more, but hey, that'd be nice and easy just to test your processor and FPGA and ADC board on its own like that. You just plug it straight into a test jig and Bob's your uncle. So yeah, I like that. We've got metal shielded can down here. Looks like we've got a screw on the top, so it looks like we can take that off. Hopefully it doesn't... Oh, yeah, it might be soldered down. Anyway, if it is, we'll rip it off, no doubt. Power all around here. We've got external trigger over here, and this would be the function gen and your waveform and that extra, waveform output that they've got there. Battery backup, of course, and not much doing at all, as you'd expect in a $450 scope. You expect, a cheap as chips front end, 100 megahertz bandwidth. Yes, even the 50 megahertz model is going to have the full 100 megahertz bandwidth. They're just software limited in that. And of course, the MegaZoom 4 ASIC, which would be this puppy here, I believe, because this one's going to be your ADC. And yes, one ADC handling 2 channels. Wait a minute, I can see some Siglent style rust. Yeah, it wasn't there at first glance, but yep, bonus rust with every low-end oscilloscope. Nothing particularly novel on the thermal airflow point of view. There's our fan down in there. It's blowing into this, so it's sucking air into the unit, practically like directly over the ARM processor here, and then that will just go disperse out, go over the heatsink fins here, and go out the back. Holes here, vent holes here. So, nothing special. There's no vent holes on the side, so it's pretty much going to come down and go and out. Whatever. It'll get the job done. But I'm certainly not a fan of the fan. Shenzhen Henglixing Electronic Co. Limited. Okay. Underwriters listed. Anyway, there's no compliant mount on that, so rigidly coupled down to the chassis, so the vibration is going to possibly be amplified a little bit by the chassis. That's not helping. You probably don't expect that in a $450 bottom of the range scope, though. As for the mains wiring, no worries. It's all heat shrunk, of course. They're nice touch. They've put the rubber grommet around there so it can't, cut through the wires accidentally. Nice earth point. Everything doing right, no worries. And wow, check out the power supply. That is one of the neatest power supplies I've seen in a long time. Look, and everything. God, someone's gone to town with a Celastic gun. Look at this. There's Celastic absolutely everything. Nice touch. They've got Loctite on the screws there. Beautiful. No worries whatsoever. Obviously, all of the active circuitry is going to be surface mount on the back, but the input is fused. No worries. It's got common mode choke. It looks like it's got MOV protection on the input, and it's just a beautiful layout. Look at it. Everything's nicely spaced and separated. Big thumbs up to that. And there's the model number for those playing along at home. Though I guess you could say that they've skimped a little bit with the direct wiring straight to the PCB on the output there. Didn't bother with a connector. Saved a couple of cents. But who the hell is Asia X? What? Asia X caps. 105 degrees C rated. A little bit close to the heatsink there, but meh. And the others are OK cap. Oh, please. Oh, this is not instilling confidence in me. I mean, they can't even keep the same manufacturer. Give me a break. And on the blue output caps there, they're Aishi brand, or however you pronounce it. Yeah, they're one of the biggest manufacturers in China, but yeah, not exactly highly ranked. And the other green ones there are Zunder. Oh my! Mix and match. What did they get at the Shenzhen market this week? And there's the bottom side for those playing along at home. That looks neat and tidy. Once again, I like the design and layout of this thing. It's just let down by some cheap-ass caps, perhaps. But anyway, yeah, we've got our spark gaps down there, and, it's all doing. In fact, that seems to have a conformal coating on the bottom of it. Interesting. And if we lift off the processor board here, you can see that there's bugger all underneath it, we've got 4 high-speed board-to-board interconnects there, par for the course. Or horses, of course. Anyway, yeah, so they could have put all this logic on one board and potentially save themselves a little bit of cost here, but no, they've gone for that second board. So there's obviously some sort of strategic design decision to put that on the second board. I'd love to hear the design team's reason for that if they're watching. Leave a comment down below. Now, one of the things people will want to check on is what is the clock like? What's the PLL like? All that sort of stuff, because that determines your time-based accuracy and jitter and all that sort of jazz. You know, not that you should be that concerned about it in a low-end scope, but we've seen Rigol goof that before in their 2000 series, for example. Well, unfortunately, you won't find that on here. Here's the main oscillator. I might get the macro lens out and have a look at that. But there basically is no PLL inside this thing. It's not this puppy here. If you're wondering, that's a TPS 6150 or something. That's the LCD bias circuitry. So there is no PLL on here. It's basically built in to the MegaZoom 4 ASIC there. So all the magic is done inside there. So you won't find your traditional PLL on here to get your high clock rate. And we've got ourselves a 4 megbit flash memory there, so that must be for the Spartan FPGA, I'd be assuming. Speaking of which, it's the XC3S500E FTG256DGQ169 for those playing along at home. And the processor is the same Spear 600 ARM processor we've seen in the previous versions. Of course it would be. It's going to be running the same OS and software and everything else. Of course they're going to leverage that. They're not going to respin that. They ain't stupid. And there, thank you very much for providing that Keysight, is the JTAG bus. So, those who want to hack away, go for it. And there's the other JTAG as well. Thank you very much. And DB, that'd be debug. So that it looks like it's tied into the MegaZoom 4 ASIC. So I'm not, I'm not sure what's going on there. So I think some people have reverse engineered it or have hacked around on the 2000 and 3000 X series. So, but I haven't been following that thread. Sorry. Interestingly, there's temp and temp B here. So they'd be monitoring the die temperature, I would be presuming. So the scope should know if it's getting too hot under the collar and probably pop up with a warning, Will Robinson, and shut down. There's nothing else exciting on the back. There's a TLO74 up there. There's some massive bypass happening underneath the ADC, I believe it there. And I would be guessing that that one there is your ADC and that one's the MegaZoom 4 ASIC. I won't bother trying to heat these things up and get the heat sinks off. I mean, these are custom Keysight parts, so really, it's not going to tell us anything. But except that it's a MegaZoom 4 ASIC. It's exactly the same as what's in the 2000 and 3000 X series from 6 years ago. The ADC could have changed. It could be a lower spec part or whatever. But yeah, we're not going to know the details. That's going to be a Keysight custom part, but the MegaZoom 4 ASIC, exactly the same. They're leveraging that because they spun that once, spent the millions of dollars developing that, and they've been amortizing the cost for like 6 years now, so it's probably cheap as chips for them on some old silicon process. So yeah, it has the full capability in there. It's got the 1 million waveforms updates per second. It's got the 4 meg of sample memory. They could easily enable this stuff. It's got the hardware decoding, the FFT, real 64K point FFT, all real time in hardware, protocol decoding all in hardware, everything else. But they chose not to enable it because that'd eat into their 2000 and 3000, or at least 2000 series sales. And also you can tell that one's the ADC because when you're laying out a system like this, it's going to be the closest to the front end. So the signals are going to be coming out here. They're going to be differential pairs, of course, coming out. It's going to be a differential analog signal. It's going to go straight into this connector here, which pops up on the bottom there, and then it goes, I think there might even be some termination down there, goes straight into the ADC here, and of course your MegaZoom 4 ASIC is going to be coupled into your processor over here, so you can almost bet your life that's the MegaZoom 4 and that's the ADC just by the system arrangement there. And for those wondering if they're going to release a mixed signal version, well, I haven't heard anything and I wouldn't expect them to. They've been working on this for years. I would have, if they had that option, you would have like seen cutouts in the front or things spaced to put that in there, but we don't have any of that. I mean, they've deliberately spaced these things out. There's really, maybe tucked away in there, perhaps you could have like an 8-channel jobby or something, but then the probes wouldn't be compatible. And no, it's just, I don't think it's going to happen. Don't hold your breath. And it's not really worth spending much time on the signal, the SigGen stuff. These are just amps and things like that to do offset and output buffering and stuff like that. And the demo signal generator down here. Now, this is the BNC. Now, they sell this as a non-generator model. I don't actually have the non-G version. The base price unit does not have the signal generator. And I am led to believe that it physically does not have it populated. So I assume maybe it doesn't have the rest of the stuff populated either. I'm not entirely sure, but we'll have to wait until somebody does a teardown of a non-G version. But I can almost guarantee the non-G version to be the exact same layout. So in theory, these are all, I believe these are all off-the-shelf parts, so you could potentially, if you are really, really keen, potentially get the non-G version without the parts fitted and fit them yourself and the BNC. I believe the front panel doesn't have the cutout for it though, doesn't physically have the cutout, but the layout in the PCB would be there. That's what I believe anyway, but don't quote me on that. But yeah, no, if this thing is going to get hacked and people, want to get a real feature-rich, the top-end model for the low-end price, they're going to be buying the function generator version with everything installed. Otherwise, it's just too much hassle, even if you could do it. Poor puppy's unpopulated. What's going on there? And there's all that LCD bias driver stuff I was telling you about. Power supply, nothing to write home about. These are wet electrolyte ones. You can tell because they've got the vents in the top. They're not the solid SMD caps, so, but they're fine. Par for the course. You've got all our LDOs. This thing has no shortage of power rails. 1.8 volts, 3.3, 1.2, 1 volt, of course. They're all for the FPGA and other digital cores and things like that. And what else? I think we've got like 2 volts over here I saw somewhere. I don't know. There's a whole bunch of stuff. And the trigger circuitry's like, meh. Always nice to see an NEC relay, though. I can list, there's 3 on here. There's one thing I don't see on here, and this is an LCD cable. This one over here, this tiny one, that's the keyboard cable. So it's going off to the front panel. So there must be a PCB mount, or the cable is on the bottom and it connects. Anyway, I'm going to whip this board off. I'll do the cans last, but let's get this off and see what's behind. There's a bunch of self-tappers in there, and bingo, we're out. And there's our LCD. We can see that that does actually connect down to the bottom of the board down there, so that's always a bit of a pain in the butt. I won't bother showing you the keyboard front panel. It's like meh, whatever. And of course they're taking RFI seriously. We've got our metal fingers there and there going down to the pads there and there. Nice, low inductance for the win. Well, they're pretty darn proud of their made in China. Well, now this is interesting. Look at this unused BNC cutout here. Were they thinking a 4-channel version maybe? And bingo, they've also got it up here in the chassis. So are they hedging their bets down the road, with the chassis at least, that they could do a 4-channel version? Because this is one of the key things that does not make it competitive with the Rigol 1000Z series, and why it's so popular is because it's a 4-channel scope. But they've done that for a reason. So, and of course you don't have the external trigger when you have the 4 channels. So, there's no reason why they couldn't respin that board and have 4 channels in there with no external trigger. Maybe also that's why they've done the processor board, so they can whack another ADC on there. perhaps, or change that, or multiplex it, or do whatever they need to do to get 4 channels. But do not get excited and do not hold your breath and hold out for a 4-channel version of this scope, because I don't think you'll see one anytime soon, if at all. They're just hedging their bets early on in the design process and probably just went, nah, we'll stick with 2 channels, because that's all tech have got. And here's the LCD, which is manufactured by One Hung Lo Anonymous. The interesting thing about this is if you read the data sheet for this thing, it tells you that there's a little asterisk, and you read the fine print down below. It says that this display can have up to 5 dead or stuck pixels and not be deemed a failure. Are you kidding me? What is this, the bloody 1990s? Ridiculous. So they've obviously used some cheap ass, bottom of the range consumer grade display in this, because they don't have, as far as I'm aware, don't have that same clause in the 2000 and 3000 X series. No one would tolerate dead freaking pixels, but apparently this, just read the fine print. We're not going to give you your money back. One of the B&C front panel nuts had 2 washers. Someone was feeling extra generous that day on the production line. Good on ya. Well, that was a waste of effort. There's nothing on the bottom. Couple of crystals, 25 and 30 meg there. And why they couldn't put those on the top, I don't know. Anyway, a couple of 74HC, couple of standard 78 L05 regulators, and that's about all she wrote. A little bit more on the analog front end on the bottom here. It looks like we've got like some sort of differential filtering thing or something like that happening. And the 125 megahertz crystal on the top side of the board, I can't find any info on that. So if anyone has any clue, let us know. Hey, 25 meg and 30 meg, they'd be for the processor and the FPGA probably. And those parts on the bottom of the analog section there, no, I thought it was some sort of differential pair thing. It looks like it's just some sort of star ground with, some like decoupling or something going back to it. Meh. And the analog front end shields just come off with a screw. Beautiful. Thank you very much. It's even labeled nut. Beautiful. They didn't solder them in. Thank you, thank you, thank you. It's just got to be hacked now. First cab off the rank here, LMH6574, and this is actually a video multiplexer. So there you go. Couple of trannies down there, are they? An analog devices part, haven't got the number for that. Got ourselves a trimmer cap which has the hole. There's only one trimmer cap on this thing which has a hole in the can to adjust. What else? We've got a relay. That's our PhotoMOS relay down there, is it? Looks pretty standard for 100 megahertz. Front end 74HCT595. The digital expanding choice of champions there. And I believe that is a Hittite HMC 626 there. So it's a 1 gig bandwidth variable gain amp. Exactly what you'd need here. Well, you don't need 1 gig, but you need a variable gain amp in there. So this one actually doesn't have a bandwidth limiter in it, a software bandwidth limiter. So they must be limiting that somewhere else. Curiously, there's an unpopulated footprint there, so I'm not sure what's going on there. And they've got that jumper link, a 0 ohm jumper link, bypassing that. So that's interesting. Once again, I don't have the 50 megahertz educational model to compare it to, but I'd be surprised if they're not identical. So the output of the variable gain amp then goes up to here, and this is a LMC 6552, I believe it is. Once again, this is a 1 gig bandwidth differential driver, which is of course exactly what you want. You can see sort of the differential type layout there, and then the differential pair buggering off. Even got a nice handy little test point there, so they can characterize that at the production stage. But once again, that does not have any attenuation built in, so like digital attenuation or anything like that. I pretty much know for a fact, I think they are software limited in this, because you can actually buy a software upgrade option from 70 megahertz to 100 megahertz. So obviously they've got to be able to at least switch those two in software. So yeah, they've got to be switching in something in there, whether or not it's a Vericap or whether or not it's just some LCRC filter or something like that, crude filter being switched in. Not entirely sure. I'd have to reverse engineer this to really see. So there you have it. That's inside the new Keysight 1000X series oscilloscope, and it's very well designed and manufactured as you'd expect. A little bit of a letdown with the quality of the caps in the power supply, but it's par for the course these days. The fan is a little bit loud, don't like that. But apart from that, they've actually engineered the board really well, and having that processor board on there is a really interesting design decision. And as I said, they probably thought about, with the front panel holes and everything, probably thought about a 4-channel version early on in the design process, and then maybe change their mind further down the track, because that's one of the key limitations of this thing, is that it is only a 2-channel model. They don't have a 4-channel option, so don't hold your breath for a 4-channel version, and don't hold your breath for a mixed signal logic analyzer add-on either, and I wouldn't expect it. It's designed, they've clearly targeted this to compete directly against the Tech TBS 1000 series in the educational market. It's not really designed for the hobbyist. If it was, I'll talk about pricing in the review and stuff like that, which I haven't shot yet. Sorry, I goofed up. I didn't realize I was 28 days in February. Oh! Anyway, this is released today, and it's $450 for the base model one without the function generator. Goes up to $700 or $800 or something for the full bells and whistles 100 megahertz version that we've 100 megahertz with function gen that we've got here. But hey, it's, as you'd expect, it's a very nicely designed and produced scope, and it does work exactly like the 2000 and 3000X scopes, as you'll no doubt see in the review. So it is really quite a high quality scope at a low end price, pretty much exactly as they advertised. So I'm reasonably impressed with this. I'll have to do a reverse engineering of the analog front end, of course, and as always with these teardowns, I'll take some high-res photos. I'll put them over on eevblog.com so for those who want to do some reverse engineering or hacking on this thing, then go for your life. Anyway, the ultimate test of whether or not this is going to be successful in the market is whether or not it can be hacked, I think. Like in the market that, like the hacker, hobbyist, maker kind of market, to compete against the 1054Z, which is hackable, and other scopes which are hackable, this one has to be hackable. And if you can get the function gen version for that, then it's going to be an absolute bargain. It could be a killer scope. And of course, as time goes on, they can release extra functionality in this because it's got the Mega Zoom for ASIC in there. They can increase the sample rate to up to 4 gig if they wanted to. They can increase the sample memory up to 4 meg if they wanted to. They could implement the million waveforms per second if they wanted to. All that functionality is already built into this scope, and of course the serial decoding is an optional extra. They can include that for free, so they have a lot of scope to move on the pricing, but clearly at this stage they're targeting the Tech TBS 1000 series. So hope you found that teardown interesting, and if you did, please give it a big thumbs up. And as always, EEV Blog Forum is the place to discuss hacks and all sorts of test equipment reviews and teardowns and stuff like that, always linked in down below. Catch you next time.